Okay, so here we have distance traveled, right, in kilometers. Here we have the fuel, right, in liters. If both of them start at 40 liters, right, but for Magender's car, right, the fuel rating is, right, efficiency rating, sorry, is 3.5 liters per 100 kilometers. So after 100 kilometers, right, Magender's car would only have 36.5 liters left. After 200 kilometers, it'd be 33. And after 300 kilometers, it'd be, right, 29.5. So it's a linear relationship going down like this because we're decreasing at a constant rate from both the y and the x-axis. Now, if I look at Min-Yi's, right, sedan, right, we can see that the decrease is a lot faster, right, because we're losing 7.5 liters per 100 kilometers. So at 100 kilometers, right, we're starting here as well, but we end up having only 32.5. Then after 200 kilometers, 25. And then after 300 kilometers, it's 17.5. So this is a different linear relationship going down, right? And again, it's linear because, right, the constant increase in the x-axis and the constant decrease in the y-axis makes it linear, okay? So they're the same in the sense that they both measure how much fuel they have left after a certain amount of time. The main difference is Magender's car, right, loses less fuel compared to Min-Yi's car. Okay, so now how much fuel remains in each car after 500 kilometers? Okay, so that's going to be all the way out here, right? So at this point, we're at 29.5. Right, Magender's car will have to lose 3.5 liters times 2 because, right, this is for 300 kilometers. We have to travel an additional 200 kilometers, okay? And now for, let's see, Min-Yi's car. Min-Yi's at 17.5 at the moment, right? But again, this is worth 300 kilometers. So this is how much fuel is left after 300 kilometers. So we have to subtract 7.5 times 2, which is how much fuel you will use after 200 kilometers. This is what you have for each car.